So hello again. Tonight we'll talk about self-important Earthlings. Yeah, it is a bit Earthling dweller biased, but we'll get into the details of it. It's not meant to be that insulting. So I am an Earth dweller, and I do have a certain bias based upon being an Earth dweller, but also being a person who's got an unquenchable thirst for science and technology. So most people wouldn't know these things, but I know a thing or two about a thing or two. So sometimes when I see things in the news media, I go, that's just meant to scare the bejesus out of people. So they'll go to that website, read that article, see all the adverts down the side, and so eyeballs on ads make money for the sites. And so sometimes it's the shock value just meant to affect you, but not meant to permanently scare you. Just a small amount of PTSD. But I also know that the moment you can, because I've done a lot of public astronomical observing events, and when you can get a person's mindset to beyond, to like greater than the Earth, to their place in everything, then they'll have a different perspective. And now on with the show. So here's, I guess you could say, the insulting part. You're not the center of anything. You're not unique. People are focused on what they have to do to survive in their daily life, for their family, etc. Know that the Earth is not the center of the solar system. Our star is not the only star in this galaxy. We're not at the center of the galaxy. We're not the only galaxy in the universe. Our galaxy is not at the center of the universe. Our planet is not the largest planet, even in our solar system, let alone in the universe or the galaxy. Our star is not the largest star. Even our galaxy, Andromeda, is like 2 times bigger than Milky Way. And everywhere we look, nothing's like special. Everything's made up of the same matter and energy and physics and chemistry. Although when you're looking at various things, you'll find that the temperatures will vary. If you're looking at planets, the atmospheric pressure, the surface composition, mountains and craters and valleys and things like that, their magnetic field, their tectonic plates, all that stuff varies, but it's known stuff. So likely we're just one amongst a vast quantity of things. The Milky Way is one of many billions of galaxies. Each of those galaxies can have millions to hundreds of billions of stars. From what we can tell right now, the majority of each of the stars in our galaxy has one or more planets orbiting them. And those planets, now that we can have moons, we know that things in our solar system can have moons and other solar systems can have planets, but apparently other planets in other solar systems can also have moons. So commonplace. And we've examined through various means the exoplanets just in our galaxy. And we found over 5,000 of them and counting. And we found 20 or so of them that are roughly Earth similar. There may be a little smaller than Earth or up to 1.5 times the size of Earth. We don't know their exact atmospheric composition, but we can look at it spectroscopically and we see things like nitrogen and carbon dioxide and water vapor and same old stuff. Someday we may actually find an exoplanet that's even more habitable than Earth. We may find that they have a better atmosphere because we're kind of torching our atmosphere. Their atmosphere may be more pristine because they may not have human industrial pollutants yet or at all. And the phrase I pick up from Doctor Who, because I'm a Whovian, is Yana, you are not alone. So just always think of it as there's far too much out there for us to be so unique, so better than anything else that we're the only thing that's out there. Far more likely that we just haven't communicated or met up with them yet, or maybe they're out on the edge of our solar system watching and unwilling to say hi to the wild animals. That's the zoo hypothesis, by the way. So in general, people are focused on other things. There, as Zen goes, they're frying other fish. Maybe not better fish, but just other fish. If it's something they're not aware of that's looking hazardous, it can be frightening. And a lot of that stuff is in the form of astronomical misinformation or blowing things out of proportion. So if you're reading some news release of some kind from wherever, and it says the whatever, name something threatening, and it's pointed directly at you, it's going to come and get us. Maybe, most likely not. As I said, you would have to be amazingly unique in the universe, and you are, in order for something to purposefully want to get rid of just you. So, yeah, there may be millions of rogue planets and rogue black holes out in our galaxy alone, but they're not in our neighborhood at the moment. There may be lots of neutron stars or black holes that have energetic jets, pointing at various places, but none of them are close enough to us to make us worry about it. And much like we know that Andromeda and Milky Way are heading for one another and may interact with each other in about 5+ billion years, but we also know that our sun is likely to go end of life and become a white dwarf in about 4.5 to 5 billion years. So which first? All I know is if it's in the billions, don't worry about it. And then, hey, they can even hit your home sidewalk, meteorites, or they can leave giant craters. If you're ever out in the Arizona area, highly recommend visiting Meteor Crater. So you can actually see, like 100,000 years ago, how something not too big, sort of the size of a small truck, hit and made this gigantic mile across dent in the ground. I knew that was what I was going to see when I went there. But for me, everybody else was looking down into the hole. I was turned around the other way, looking at literally the ripples and the stone in the rock from the impact of the meteorite hitting. And it just liquefied the stone briefly to cause the stone to ripple. And you can still see the ripples in the stone going out, maybe 10+ miles. And Arizona in that area is not known for a lot of volcanoes, but there is a lot of surface rock that melted and then hardened again. So you can find these, what looks like a volcano that wasn't a volcano all around the area where the impact happened. And if you think about the moon and the fact that it has lots of impactors, and those will heat up the rock to the point where the rock becomes molten and then it solidifies again. So, as I said, we see things and then we look out in the universe and we see same old, same old. Once we learn how the process works, it works out there like it works here, or it works here like it works out there. And space be big, Earth be tiny. I always like to make these sorts of comparison, like when they show satellites in orbit around the Earth, and they show the Earth being like 4 inches across, and then they show 200 satellites, and you can individually see all the satellites. If the Earth was really shrunk down to that size in that picture, you couldn't see a single satellite because it would be smaller than 1 pixel. But if you want to scare the bejesus out of people, make it look like there's just so many satellites, it's going to block out the sun. Things in the universe are big, and individual things are usually fairly tiny. So if something is moving less than the speed of light and it's millions to billions of light years away, I wouldn't worry about any hazard to the Earth, regardless of how big it was. If something was cruising through our solar system and it was smaller than an extinction level event, it's most likely going to just fly through the solar system because there's a lot of open space in our solar system. But even if it were close to the inner planets, it's probably going to fly into the sun because the sun has a much larger gravitational field than does the Earth. But let's say it arrived a little further out in our solar system. Well, if it arrived, at Mars or farther out, it's most likely going to dive into Jupiter, Saturn, Uranus, or Neptune because their gravity is far more than Earth's. Any intruders in our solar system, if you remember Oumuamua, it passed through our solar system and didn't affect anything other than our curiosities. So let's say something wasn't an extinction level size object and it did hit the Earth. Okay. If it's not an extinction level event like the dinosaurs received, then it might be very localized, as in it fell to Earth We know not where. We didn't care. The seismographs detected it and then focused on it. Yeah, it happened out in the middle of northern Russia, where there isn't anybody, out in the tundra. It was only 50 feet across. So yeah, it made a giant hole in the ground. Giant meaning, maybe 200 feet across, but there was nobody there. And so what? But things are hitting the Earth on a regular basis, and none of them so far are extinction level for humans. But let's say something did hit, I don't know, instead of on land, it hit the ocean, out in the middle of the Atlantic or Pacific Ocean. You might have a tidal or tsunami event. But if it came in an angle, then your tidal or tsunami event would be greater because it's going to push up more water. If it hit straight down, bloop, it's going to come back up there, and it may, by the time you get to the shoreline, it may not even be anything more than a little bit of a wave. If it hits a lake, like, something 100 feet across were to land in Lake Michigan, it might be a shoreline flooding event for a while, kind of like we have with hurricanes. The water would come in, go up, and then go back out again. Or, out in the deserts of Africa, they do have places where they find glassified sand. This is where a meteorite hits the desert sand with so much heat and force that it melts the silicon dioxide of the sand and glassifies it. So yeah, you can go in the Sahara Desert and find glassified sand, but you don't find gigantic craters, because if it did hit, the sand would come out, and then over time the wind and such would make the sand flatten back out again. The wind is most likely to push up a dune than it is a meteorite's going to leave a permanent impact in the sand. Or it could hit, out in the north central part of the U.S., out in the middle of some agricultural area, and some farmer's got a big hole in his field, and the big hole is maybe 50 feet across or something. But that's what you're going to experience. If it happened to land in a glacier-covered mountain area, or Arctic or Antarctic, you may have an avalanche, or you may break off a glacier iceberg. But if those things happened, it's going to be very localized. And unless you were actually seeing what's going on, like picked up the meteor on its way in on radar, it would go unnoticed. And I think the number is about 3 tons of micrometeoroid dust falls on the Earth every day, but it's so distributed across the Earth, it's just dirt in the air. We don't even think about it. And let's say something was headed our way. You know how when you want to shoot a target and the target's moving, you got to lead the target? Well, Earth is moving about the sun. The sun is moving about the galaxy. The galaxy is moving through space. If something originally were coming for us, and before it got involved in the gravity of the Earth wouldn't be there anymore. We would continue along our merry way like nothing happened, and it would pass without incident behind us. If you think something's headed for the Earth, the only way that's really going to happen is if something is guiding, something is navigating its way to Earth. And if that's the case, they're probably going to slow down and land, not, target and hit us, unless that's the intent. But what about those energy beams from space, white dwarfs and neutron star pulsars and quasars and X-rays and gamma rays? Okay, they're far away from us, many, many trillions of miles at the closest. Much farther than that if you're talking about things that are thousands to millions to billions of light years. We can actually receive the radio signal from quasars. These are the black holes in other galaxies that may be millions to billions of light years away. We can also receive pulsars from neutron stars in our own galaxy, but they don't affect us that much. And we'll get to why that's the case in a couple of slides. But essentially, if the emission is traveling like the speed of light, like they would normally travel, if you knew it came from a neutron star or a quasar and they were that far away, you wouldn't worry about it pointing at Earth because Earth is not going to be there. We're going to be elsewhere a million years from now. And then, okay, let's say there's a high energy beam of gamma radiation coming off of an exploding star. And when it first came out, it was pointed in our direction. Well, even if we didn't move, there's a thing called dispersion. And even a laser, a coherent light source, when you point it somewhere, the divergence of the beam is going to be small over a reasonably long distance, but that reasonably long might only be 100 feet. Beyond 100 feet, even a millimeter diameter laser beam is going to spread out. Well, imagine having a very high energy beam coming off of a quasar or a pulsar, and it's 100 light years away. Well, that narrow beam of energy is not only going to be bigger, it's going to be bigger than the Earth. It's going to be so big that it's probably going to be broader than our solar system, which means that all that original energy is now dispersed over a much larger area. And as an amateur radio astronomer, I can tell you, even if you know a pulsar is out there, even if a big observatory detected a pulsar and you know exactly which neutron star is that pulsar and its spin rate, so you know what radio frequency to tune in, and even if you do all of that stuff, if you've got your normal little like Yagi antenna, you're not going to pick up that pulsar because the energy has dispersed, and you're talking about nanowatts, billionths of a watt spread over a very large area, which is why the big radio telescopes are big. The one in China, I think, is 500 meters across. So that's how they get to listen to all these high energy things that they talk about out in space that, well, if you were standing right at the quasar when the beam came out, yeah, you would be fried. But if you're 100 light years away, not so much. So let's say we wanted to come up with a threat scenario. There's a constellation called Canis Major, big dog, out in our night sky. And there's a star. We just think of it as Sirius, but it's actually multiple stars. Sirius A being the bigger one. And it's about 8.6 light years away. That's 8.6 times roughly 6 trillion miles away. It's a long distance. It has a companion star that's orbiting it called Sirius B. If Sirius A, which is a main sequence star, were to go end of life and slowly become a red giant star, puff out, so to speak, then Sirius B, which is a white dwarf, could pick up some of that outflowing plasma from Sirius A's solar wind, and then that would build up as a shell on the outside of Sirius B, and over many hundreds of years, that would build up to the point where you would have nuclear fission, and it would detonate. And that's a nova, not a supernova, but a nova. This is what we're all waiting on for T Corona Borealis, is a nova of this same sort of thing. So the same kind of thing could happen with Sirius, that's only 8.6 light years away. But the problem is Sirius A is in the middle of its main sequence, so it's not going to even transition to a red giant for about 500 million years. So don't worry about it. And even if it did, the distance that Sirius B orbits Sirius A is about 20 AU, or 20 times the distance from the Earth to the Sun. That's about the distance from the Sun to Uranus. At that distance, and given how small Sirius B is, it's going to take a lot longer for it to build up enough plasma from Sirius A as it becomes a red giant to make it detonate. So you'd have to add maybe another 500 years instead of, like T Corona Borealis is supposed to be 80 years, you'd have to make it about 500 years. So instead of being 500 million years, it could detonate in 500.5 million years. So to quote the infamous A.E. Newman, what, me worry? Nah. But that's a scenario that could actually happen. Certainly not in our lifetime. And so far down the road, we will actually be in a spacecraft watching it up close happen with like force fields that prevent us from getting destroyed. So don't worry about it. So where this all leads to is NASA has a new video they're coming out with. The trailer's already available. I do have a link at the end. It's called Planetary Defenders. There is kind of a running joke that there are more people that are employed as shift workers at a single McDonald's than there are people who have a dedicated, exclusive job of watching out for hazardous impactors for Earth. So if you say, well, your average McDonald's has 5 people on a shift, and they have, if they're open 24/7, they've got at least 3 shifts. So that's 15 people. And then you have some people that are substitutes or for vacations or sick or whatever. So let's say 20 people. There are roughly 20 people on planet Earth that are actually watching out to make sure nothing's headed our way and going to hit us. So there are people that understand the rarity of it. And then there are people that just say, I'm not going to spend budget money on something that may never happen. So they don't fund it. But if we ever did find anything that was a potentially hazardous object, an object or an asteroid or a PHO or a PHA, that it would have to be about 1 kilometer in diameter or about a little over half a mile in diameter. And as soon as they found it, before they even come up with like, well, we saw it move, we know it's in our general direction, but we don't even have an orbital plot for it yet. There are communication networks for notifying various people on the planet, not just observatories, but media, scientific personalities, all kinds of people to go look. It's not a matter of don't look up. It's a matter of we can make a lot more money off of the advertising if we have you look up. And if you can see it, it's very serious. If you can only see it with a giant, professional telescope, less serious a few years down the road. If the average amateur astronomer with a small size telescope can see it and track it, again, it's probably not going to impact us because you have to lead a target. But when word goes out, and I'm on that network, so I would actually get a notification, everybody look up, everybody try and track this thing, get it from multiple points on the Earth, because the Earth rotates. And if this thing is coming in from that direction, not everybody on the planet's going to be able to look at it at the same time because the Earth rotates. So every so many hours, you'd have to have a different observatory looking at it. But, once we figure this out, it may be a lot of years before it would ever get close enough to do us any harm. And I'm not sure we have the wherewithal politically to spend the maybe billions to trillions of dollars it would take to develop new technologies that would defend the Earth from it, because you would have to do it on a very short-term basis. And everybody knows when you want to get international governments to do things physically on short notice, it costs even more money. So again, not going to worry about it. So in summary, Earth and its inhabitants are not the center of anything. If something's likely headed our way, we might not be there when it passes our neighborhood to hit us. The most common one is solar flares. Prominence is coming off the sun. If we're looking at the sun from the Earth's perspective and we see a prominence, don't worry about it. It's the ones that are on the other side of the sun, because the sun rotates, that are on the other side of the sun. When they come out, we could be lined up later on. Know what the target is, or know what the source of the attack is somewhere out there, and then balance it all out based upon distance, arrival time, dispersion, all these sorts of things. But in the meantime, hopefully you've gotten enough information. When I put this out to the public, they'll have enough information that maybe it will be less likely to instill fear in people, so that they'll go, okay, so there's a meteor in our solar system. How far away is it? Oh, it's about 12 million miles away. Okay, is it expected to come close to Earth? Nope. Then I'm not going to worry about it. It's just an oddity that I'm going to go read the article and go, yep, okay, done. But if something were hazardous, and be it an object or a energy beam or something like that, if it's really going to do us in. If it's a meteorite, if it's a meteor and it comes in from the direction of the sun and it's headed for us, we probably won't even see it coming. There have been meteors that have passed lower than geostationary orbiting satellites, and the meteor might be 100 feet across, and it comes in out of the sun, and the only reason we know it was there is we see it on its way past us. So it already went below geostationary orbiting satellites, didn't hit anything, zipped through our upper atmosphere, and we saw it as it was leaving. So if it's going to get you, it's going to get you. Don't worry about it. But in the meantime, fear is the mind killer. Don't worry, be happy, and learn more about it, and there will be less fear, uncertainty, and doubt about it. Less FUD. Always good to have less FUD in your life. Okay, what's a different topic? No gravity waves tonight. And like I said, we'll probably be talking about quantum computers in a week. Comments? Questions?
Yeah. You minimized the concern.
Yes.
I don't say we should live in fear, but we know that there are things flying around all over the place of all different sizes,
yeah,
all different energies. And I think sooner or later we're going to get hit by something reasonably big, enough to damage something. Maybe we should have some kind of concern about it.
As I pointed out, for comparison, there are more people working at McDonald's than there are people dedicated to looking for things that could hit us. I do think we should spend more money to have 24/7, and don't forget to include the poles too, because things can come in from that direction. And keep an eye out on anything that could potentially be a problem. I mean, we do that with hurricanes. The moment you see a tropical depression on the coast of Africa, we're like, it's coming for us. Even though it isn't, even though it's going to fizzle out and head up to the North Atlantic and be cold and die out there, where it's going to hit the Yucatan Peninsula and come out in the Pacific Ocean, and or if it's going to, there's an upper level trough and it's going to fizzle out before it ever makes it to Florida. But we still look out for them. And how much money do we spend annually just looking out for hurricanes? If I just sliced that and said, how much money is the U.S. government? How much money is NOAA spending? And it's probably a single-digit number of billions per year for all the aircraft and the satellites and the GOES satellites. They're watching the weather 24/7. We're spending money for good cause. The number of things that can hit over a large area and cause substantial damage, even if we get a higher than usual number of hurricanes per year, it's in the small numbers of billions of dollars, which, if we had better insurance for our property, would be spread over the entire population of the U.S. The way that they're run now as a business is whatever money insurance providers take in Florida covers the damage to Florida. Well, why don't they add up all the insurance money taken in from all the insurance customers across the entire United States and then level that out for whatever damage there is to more hurricane-prone areas? I know that sounds kind of socialist, but that's how insurance works. The more people you have that have policies in your insurance program, the lower your insurance cost will be, and the easier it is for them to pay out a large amount for a smaller group within the total. So that's why it's, group insurance. That's why, if you get insurance as an individual, it's supposed to cost more than if you are an employee at a large corporation and you get group insurance, because the burden of the payout is spread over a larger number of people. Well, they seem to have taken an approach of every state has to fend for themselves. So while you may have a large insurance company that offers insurance throughout the United States, they're different, limited liability corporations on a per state basis. So whatever the insurance income is in Florida has to pay for all the insurance damage in Florida. So that's why insurance companies go broke. The entire insurance company doesn't go broke unless it's only local. The nationwide, I shouldn't use nationwide because that's the actual name of an insurance company, but the U.S. national-wide collection of insurance companies isn't going broke. They're making profits because they say, we make our money wherever there aren't disasters.
And I think the insurance companies in general have more employees than the amount of people working in McDonald's.
Oh, yeah.
Whose job it is to find ways to deny claims.
Yes. So that's how you make money off of disasters is you hire people to do the actuarial tables for disasters, the risk assessment for them. And then you have another group of people you hire to say, I don't think we're covering that.
That's right. Yeah.
So, yeah.
Sure. After Joe's birthday, they stopped covering terrorism. After COVID, they stopped covering viruses. Yeah, they just cover it anymore.
Yeah. Which is why when I paid off my house years ago, when I had a little money, I paid off the mortgage on the house. And then I think it was less than 10 years later, I said, why am I paying this huge amount of money per year for property insurance? I'll just put, a small amount of money that grows over time in the bank, and I'll just keep a little nest egg over there that I'll have my own self-discipline, not spend all that money. And so if all of a sudden I need, $20,000 to re-roof my house, I can find a way to do that between robbing from there and then, borrowing what I need or putting short term and paying it off. I can do that kind of thing. Most people are not able to do that. And I understand that. If you have a mortgage, the mortgage company, the bank, wants to make sure your property is a sellable asset should you lose it. So if you stop paying your mortgage, they want to make sure your house is in good shape, even if it underwent a hurricane. So they demand, in order for you to have your mortgage agreement, for you to pay for insurance. They tell you how much you have to have for the structure, but not for the property inside of it. They just give you a ballpark on that. And then you can't buy less insurance than that. So is there going to be cosmic insurance anytime soon? I guarantee you that if we get a few cities hit by some things that destroy, individual buildings or blocks of buildings, and that happens a couple of times in a single year, you're going to see the major insurance carriers wanting to now sell you cosmic insurance.
Asteroid insurance. Yeah.
Well, no, see, they're going to want a blanket policy. So you're going to want cosmic insurance that has an asteroid rider on it.
Yeah.
Yeah.
Meteor insurance. That's great.
And no, it's a meteor rider on the cosmic insurance policy.
It'll be considered an act of God and they wouldn't claim it anyway.
Well, see, that's the thing is they won't tell you that. They'll just put in the policy, we don't cover acts of God.
Yeah.
And then you say, but I'm an atheist. So cover it. Anyway, but I thought it would be a fun topic just to point out, fear not, because the universe is a big place and we're not that important in the big scheme.
I myself, I'm not afraid, but I think I should put my concern on a back burner and keep it cooking.
Well, I would want my tax dollars spent to make sure that there are people looking out for all of us. Yes.
Yeah.
But me individually, I've got a back burner project of the acoustic detection of bolides. And a bolide is a meteor coming in and blowing up in the upper atmosphere.
Mm.
And people say they happen all the time, but they're so small, they don't have any visual impact. They just have an acoustic impact. But in your average noisy everyday life, you don't even notice them. They're just like, was that a car backfiring? Was that a shot, a gun shooting? No, that was just a bolide in the daytime because you wouldn't see it in the daytime. But as soon as you start saying, look at all the bolides I've detected, kind of like, hey, gravity waves. They didn't know how many gravity waves were occurring until they had detectors that could detect them. And now, about 3 times a week, I'll get gravity wave notifications. So you never know what's out there in the universe happening all the time until you can detect it.
But there's a difference between nobody looking for us and us being insignificant. And if someone found us, what would happen to our civilization? And I agree with Joe. I think it's a cookbook.
Yeah.
We are meant to be served, or we are meant to serve.
Well, they feed you on the ship. You get
Yeah. Well, they want you nice and well fed, like cattle.
Mr. Chambers, you're getting too skinny.
Yeah. I often think of it as I switched from being a carnivore to being a vegan, and I dropped 40 pounds over the course of a year. And I said, well, it's not because I'm eating less food. I'm actually eating more quantity of food than I was before. I'm just not eating meat and dairy, which says to me, that thing about they don't put hormones in the animals anymore. Well, I was being fattened up for slaughter without even realizing it. And I think people that are carnivores that are out there eating how quick can we take this calf and make it, a full-size steer so we can make our money off of it? How big can we make these chickens so that we get, bigger chicken breasts? That's just the, business of creating animals for food. And so, when I stopped consuming the animals that were being grown for slaughter, I dropped a lot of weight. And the thing that I didn't count on is, all those crops that we like the crops to come in really quickly, grow that wheat, grow that corn as fast as possible. I may have dropped weight, but I grew 1 inch taller.
Really?
Yeah. I was for a lot of years 6'3", and then as I got older, I got down to 6'2".
Gee.
And about a year after I was on, switched to vegan, I noticed that I was back to 6'4" again, back to 6'3" again. And 6'4" with shoes, but 6'3" again. And then I thought, is it that I dropped the weight and I'm standing up taller? Or is that I've now eaten so many plants that have been rapidly grown that I've been rapidly grown?
No, your discs are not carrying so much weight, and that's the reason why they are fatter.
And that's why I, say I don't know whether it's I'm standing taller because there's less weight compressing my discs vertically.
Yeah.
Of course, that's just my opinion. I could be right or wrong. Okay. Any other comments or questions? Otherwise, I'll stop recording. Hearing nothing.